Okay, we are recording. So I want to implement this in Python, the this algorithm in Python. So for that, we are going to do a program. Maybe I bring the slides here so I don't have to switch back and forth between the virtual machine and the host machine. So crypto, let me see, I'm going to bring what I need. I need the slides of this. Okay, I will need also this. Okay, I think it's the only thing that I need. Now I'm going to maximize the virtual machine. So let me open several windows so we work in them. So I need to do a program that will implement this, a Python program. So the first thing that I'm going to do, of course, is the hash bang. So Python will be in bin, in user bin Python, no? In user bin Python. And we are going to use Python 3. Okay, so the first thing that I want to do, since we are going to work with string of bits. So for example, if I want to represent, it will be like that, okay? We are going to work with string of bits, not with hexadecimal, directly with string of bits. So I will need to do the XOR. So since Python does not provide XOR of a string of bits, I can define a function that will do it. So define, let's call it XOR. So this function will receive a first string and a second string. Inside we have binary integer, no? And I want to return the XOR. So do you remember how the XOR work? So 0 XOR 0 will be what? Zero XOR 0 is 1. The XOR, yeah. What is the definition of XOR? If I do A XOR B, it will be what? It will be not A and B, or A and not B, no? More parentheses, so it's a little more clear. It will be that. Is it? No, it's not that. No, it's A and B, and not A and not B, no? This is XOR, no? Nobody say anything. I'm even doubting now about my XOR. Let me check. We didn't install the. Let's install it. I'm going to update my list of references from the repository, and I'm going to install Firefox ESR, I think so it's. Yeah, Firefox ESR. So it should appear. Okay, Let me see if it appears directly. Yeah, facts for sorry. Yeah. So XOR definition. Here we have the table. So yeah, it was the first definition that I say. So it will be 1 when they are different, and it will be 0 when they are equal. So here it was the first definition that I say. So it will be when they are different, it's 1. So here it's 1, here it's 1, and here it's 0. Okay, this will be the XOR. So if I pass you, for example, 2 string, like let's put only 4 bits. This first string and this string, what will be the result of the XOR? So the first bit, 0 XOR 1, this 0, the first 0, XOR 1, will be what? 1. When they are different, it's 1. Then we have 1 XOR 1, it will be 0. Then 0 XOR 0, when they are equal, it's 0. Then 1 XOR 1, it's 0, okay? So when they are different, it's 1. So we have to write that. So of course, if you do the XOR between 2 strings, they should have the same length. So let's say that there is, when I call this function, I do check that they have the same length. Let's compute the length of, for example, string 1. What should we do to get the result? We need to generate a new string, no? So we can start with a string that is empty, and we can concatenate, go over all the bits and concatenate the result, no? So I can do for I in range of length, and do what? Result, concatenate at the end. What I'm going to concatenate is what? So let's put a if here. If they are different, I put a 1 as a result. So if str1 sub I is different from str2 sub I, if they are different, I'm going to concatenate a 1. Otherwise, I'm going to concatenate a 0, no? At the end, I will return what I have in result. So let's see that this works. Let me remove all of this. So I create a file, it's called des.py. I want to try and to see that my file does work. So look what I can do. I can call Python. Oh, I can call Python 3 with the option interactive and pass the file. So it will load the file. So my function is available, the function that I just create, XOR. So I can do, for example, XOR. Let's do, how many bits I put here? 1, 2, 3, 4, 5, 6, 7. Let's put 8 bits. With, for example, this one, this one, this one, this one. Okay, let's see the result to see if it's correct. So 0 XOR 0 will be 0 because they are equal. 1 XOR 1 will be 0. So it's worked well. Then we will have 0 XOR 1. They are different, it have to be 1. Then we will have 1 XOR 0. They are different, so it have to be 1. Okay? Then we will have 0 XOR1, they are different, so they have to be 1. Then we have 1 XOR 0, they are different, it have to be 1. Then we have 0 XOR 1, they are different, it have to be 1. And then we have 1 XOR 1, they are equal, it have to be 0. So it did work, okay? So we can verify, we just verified that our XOR function worked. So we did the XOR function and it worked. Now, since we have to apply a table to string of binary number, we can define a function that we are going to call apply table. So this function will receive a string, let me call it string, and a table. So for example, in the algorithm, let me show you the algorithm we did bring in here. Is this the file? Yeah. In the algorithm, we are going to apply PC1. So PC1 will be the table. So I need a string, I need a table, and I'm going to apply the table to the input and get an output. So let's do that. So if you want, instead of calling street, I can call it input. I have an input, a table, and I want to generate the output according to the table. So what should we do here? So there will be an output, no? I can start with this output as empty. I will do a loop. It will depend on how many elements is in the table. So let me compute the length of the table with the function length of table. And let me do a loop for I in range of length. I will do what? I will update output, no? So output will be what? It will be the previous output, and I'm going to concatenate the next bit after applying the table. So how do I do that? It will be input sub something. This something I needed. And then I return the output, no? So this something will be what?
Wouldn't it just be I?
No. Otherwise you make a copy. If you just put I. I have to use the table. If in the index the table does not appear, there is a problem because, for example, let's look here. The first bit of the output will be bits 57 of the input. So this 57, where do I get it? In the table. So of course, I need a bit in the input, and the index of this bit will depend on the table. So what should I write here? Table sub I. Now table sub I, in Python, the index starts in 0. Here the index starts in 1. Okay, they don't talk about index 0. So I am going to make a correction, -1, to bring it to start in 0. So I think the apply table method is okay. So let's verify that it worked fine. So look, I went out of Python because I make change in the file. And I'm going to start Python again interactively. So it will load the two functions. It will load the content of the file des.py. So I should have the method apply table. Okay, let's use the method apply table. So I did bring some table already done, so we don't have to type them. So for example, if we want to apply, let's see an example here. Look here. For example, we go from this key, the original key, to K plus, applying PC1. So I want to verify that my function work well. So I'm going to take as an input the key. So let me copy it if I can. Oh, hopefully I will be able to copy it. Oh, otherwise will make me go to PowerPoint and I will have to switch. I have to go to PowerPoint. I'm very sorry for that. So let's take a little longer. Copy it from PowerPoint because I can copy it from the PDF file. Where is my? It's there, my PowerPoint. So I was in this slide. So we have this key. Let me copy it. And of course, when I bring it to the virtual machine, I need to remove the spaces. So what can I do to remove the spaces? I can do it manually, or what else? If you want to look, if I do echo and I put this string, it will have the spaces. I don't want the spaces. So what can I do? I can say with the traduce tools to remove the spaces. Here I have the input that I want. Okay? So here, to verify that the function works, I'm going to specify I'm using this string. Then I need the initial permutation. So I have the initial permutation here in a file. It is there. So let me find it. Here it is, the initial permutation. So I'm going to copy it so we don't have to type it. Okay? It's a list for Python. I'm going to go back to my interpreter and I'm going to put it. Okay, I need to put it without the enter. So I need to go there. I need to find a shell so I can do it. So I think it was the first one. Echo, I might just do that. Here it is. So I need it on one line. Okay, here it is on one line. Okay. So I go here and I paste it. So look, I'm going to call apply table with this string using this table. Let's do it. Look at the result. So this result should be this K plus. So we can compare it bit by bit to see if it is it. But I'm going to use something a little faster. I don't want to lose my time comparing bit by bit. So let's define a function in bash that will receive two strings and will tell us if the two strings are equal or not. So if you remember, tests do that. For example, test this string with this string. So I can look at the error status. It will be different of 0, okay, because they are not equal. And if they are equal, it will be 0. So I can do that. For example, to make it easier for me, echo equal, otherwise echo different, otherwise echo different. So look, when they are equal, it will say equal. And when they are different, it will say different. Okay, so this is what I need to implement. Let me define a function in bash. So let's call it, for example, compare string. So compare string. First, I want to explain you how I receive parameter when I do a function in bash. So the first parameter is called $1 if I have a parameter. The second will be called $2. So let's do, for example, for now, echo $1 and echo $2. So I define a function. Let me call it compare string. For example, ABC, XYZ. It will just show the two strings because I told it, show me the first parameter, show me the second parameter. If I call it with 3 parameters, it will still show me the first and the second. Now, if I call it with less, there is no second parameter. So the echo show nothing. Okay? So now that you know how to manage parameters, I'm going to say test the first string to see if it's equal to the second string. Okay? And if it is the case, show me equal. Otherwise, show me different. Okay, this is one instruction. So now we can do compare ABC with ABC. Equal. And if I say compare ABC to XYZ, different. Or XY, different. Or AB, different. So we have something that will tell us when two strings are equal or not. So let me see if I can copy it here, or I have to go back. Well, you want me to go back to the PowerPoint? Let me copy it in the PowerPoint is here. This is the result. So I want to compare this result with the one that I got when I call my function. So I'm going to do a compare of the string that I just copied that was in the PowerPoint with the string that I just generate with Python, no? So the string that I just generate with Python is here. So with this string, this is what my program say. So I just want to compare it. They should be equal. So what happened here? That the first string has spaces. So of course it will say, let me see, put 1, compare. Yeah, there are 2 arguments, isn't it? Too many arguments. Oh, I see. It doesn't consider that as a string. So I have to remove all these spaces to compare it. So I can do it manually, or I can also, for example, do what? Execute a command here saying echo this string and send this string to translate, and translate will remove the space. So this will be a string. Oh, say different. They are different? Are they really different? Oh yeah, they are different. Why did I? Yeah, they are different. So did I did the correct things? Oh, I'm sorry. It's not IP that I should apply. It's PC1. Here we apply PC1. So I did a mistake when I copied I copy IP. I should have copied PC1. Here we apply PC1. So let me copy PC1 and put PC1 on one line. So let me do that. This is PC1. It's on one line, and I'm going to substitute it in the call here. But let me do it again. I wish we have a bigger screen so we can see window on side to side. So let me put PC1. Okay, so the result is this one. So I have to compare with this one to see if they are equal. So I'm going to do it again. Copy, and we return here. And instead of this string, that was the wrong string, I'm going to copy the correct one. Oh no. The one that I have to replace is this one, sorry. So I'm going to replace this one. Of course, I need to execute the command echo this and send it to tr where you suppress the space. Okay, so as you can see, you can compare it manually if you want. This should be the first 8. You are going to lose a lot of time. So that's why I tried the computer to help me to do it. So this function is okay. I just debug the function and it's work okay. So what else we will need? We will need another function that I'm going to apply. I call it apply box. So in this function, we will pass an input. The input will be 6-bit long. And I will receive a box. A box will be a list, no? Of how many input, of how many integer. So I want to do this operation. Okay, I want to apply, for example, this box. So when they pass me S1 or when they pass me S2, it will be a list of how many integer. So 16 times 4, isn't it? It will be a list of 64 integer, no? So if I give you an input, which is a string of 6-bit on a box, I want you to compute the result. The result will be a string of 4 bits. So what should you do first? You need the index of the row. So let's compute the index of the row. How do we compute the index of the row? So remember, what is input? Input is bit 1, bit 2, bit 3, bit 4, bit 5, bit 6. How do we get the index? Row. We take bit 1 and bit 2, we put them together. You remember that? So I need to say that. How do I say take bit 1 from input, take bit 1 and bit 2, bit 1 and bit 6? If I pass you as input, I pass you the string 0, 1, 0, 1, 1, 1. It has 6 bits. What will be the index of the row? 0, 1, which is 1. What will be the index of the column? 1, 0, 1, 1, which is what? 11, isn't it? So how do I compute the index of the row? So I need this 0. How do I get this 0? This is input sub 0. What should I do with this 0? I need to convert it from a character to an ASCII code. How do I do that? I convert it from a character to an ASCII code. I use the ORD function. We saw this function already. So it will give me the ASCII code. Now the ASCII code of 0 is what? The ASCII code of 0 is what? (48). What is the ASCII code of 1? 9. So what should I do with the ASCII code? I want to transform it to an integer between 0 and 3. I have to subtract 48. That will be the first bit, isn't it? And this first, what should I do there? Multiply it by 2. Plus what? Need bit 6. Bit 6 will be what? Input sub 5. Okay, this is a character. I'm going to ask for the ASCII code. Then I'm going to subtract 48. And that's it, isn't it? Do you see that? Do you understand why I'm doing that? Okay, I need the index of the column. Help me with that. How do I compute the index of the column? So I need this bit, and I will multiply it by what? By 8, plus this bit, I will multiply it by what? By 4, isn't it? Do you understand what I'm doing here? Plus the next bit that I'm going to multiply by 2, plus the next bit. Okay, I don't have space here, so let me say that I continue in the next line. So plus, let me just copy that and modify it so I don't lose time. This one, it will be multiplied by 1. Like here, I can say multiply by 1, no? So this one will be 1, 2, 3, 4. Isn't it? And here I'm going to multiply by 2. Okay. Let's verify that, because you don't participate. It's difficult for me to keep going if you don't participate. Okay, the row, the index, let's put the index of the row is, and we are going to show it. So I'm going to show an integer here in the place order. Format, we call it index row. And the index of the col is index col. So let's see that this function works and compute the correct index. So for that, I'm going to exit and come back. And there is a problem. Oh. Is okay. 1, 2, 1, 2. This is in the first line. Here, say that there is a problem. Oh yeah. So here I open one parenthesis, two parentheses, I close one, I close another one. I open two parentheses. So there is one that should not be open here. Okay. Let's see if this time it works. Okay, so I have a function that is called apply box, and I want to debug it. So let's pass, for example, 1, 2, 3, 4, 5, 6. And here, let's pass none. So let's verify. Index of the row is 2. 1, 0 is 2. Correct. Index of the column is 5. So look at the middle bits. 0, 1, 0, 1 is 5, so it does work. Let me call it with other value. For example, let me put index of the row is 3. So 1, 1 is 3, correct. Index of the column is 15. Yeah. So do you understand what I did here? For example, let's see index of the row. I take the first character. I get its ASCII code. With minus 48, I get a value between 0 and 1. I multiply it by 2, of course. How do you go from 1, 1 to 3? You take this one, you multiply it by 2, plus this one. How do I go from 1, 1, 1, 1 to 15? I take this one, I multiply it by 8, plus this one that I multiply by 4, plus this one that I multiply by 2. So this multiplication by 8, 4, 2, and 1 is something totally natural. Okay, so I have the index. Now that I have the index, what should I do? I have the row and the column, so I can find the element. So remember, when they are going to give me the X box, let's see. If we apply it to S1, S1 will be like that. It's a list. So this is really a list. It has one dimension. How do I convert something that is b-dimensional to one dimension to get the element inside? I need the element, no? I need the value in the table, in the X box. It will be what? It will be box. Of course, I would like to do sub index row, sub index column, but this will not work. Why? Because it's a list, it's not two-dimensional. So I will do what? Index row times 16 plus index column, isn't it? Because each row has 16 elements. So if you tell me it is in row 1, I have to skip the first 16 elements. If you tell me it is in row 2, I have to skip row 0, row 1, and come to row 2. So it's number of row, index of row, times 16 plus index of column. So this gives me a value, which is an integer between 0 and 15. How do I convert this to a string? For example, let's see in Python. Let me remind you how to use Python. So the format method is very powerful. For example, I want to convert 100 in hexadecimal. What can I do? If I do that, it will convert it to a string in decimal. Here it is. It's a string. Simple quote to double quote is the same thing in Python. And inside we have the character 1, the character 0, the character 0. I'm talking about character because it's a string. Okay, if I want to convert it in hexadecimal, I do that. 100 is 64. If I want to convert it in binary, I do that. This is 100. You remember that from Python? Okay, if I want to convert it in binary, and I want the field to be, what happens is, for example, if you have 1, you want 0, 0, 0, 1. You have 2, you want 0, 0, 1, 0, because from 6 bits, you will go to 4 bits. So how do I force that? I can say I want the field to be 4 character long. So it's put space, space, 1, 0. I want to say don't use the space when you have to do padding on the left. Use the 0. You see? So if I found 2, it will put 0, 0, 1, 0. If I found 3, 0, 0, 1, 1. So I just need to use the format method. So here, I will return what? Return what? the value that I'm going to convert to binary. And this value I'm going to convert to binary, doing what? So 0 for B. 0 saying that if you have to do padding on the left, put 0, don't put space. 4 to say a total of 4 characters. B in binary. So apply box is done. Let's verify it completely this time. So we do have here example of applying the box. So for example, let's do this example. If this is the input of 6 bits and we use the first box, this should be the output. So let's verify it. So I already saved the file, I have to reload it. And I will need the X box, the X1 box. So let me copy it from here. Okay, so I'm going to reload the file and we are going to call apply box that I just did. So here I will pass the input. So the input is 011-001. So 011-001, isn't it? It was 011-001. And I need the first box. So I need to work on the box. Let me see if I can find. Yeah, let me edit it so we have the box on one line. So this is the S1 box. I'm going to put it on one line. Okay, it is on one line. I'm going to copy it. So it has a total of 64 value. I'm going to copy it and pass it as the second parameter here. Look at the result, 1001. Let's see what the slides say. It will be 1001. Now, if you take this input 110001, let's put it. So let me just change the input. The input is 110001 with the S1 box. The output, according to what we did, is 0101-0101. So we know that our function work. Okay, apply box work. Okay, so I think with these three functions, we are ready to go. We can start doing our algorithm. Three basic functions. So let's see our algorithm again. The first step is to generate the subkeys. We need subkey 1, subkey 2, up to subkey 16. For that, we are going to take the key, which is 60-bit long, and we are going to apply PC1, and it will give us a second key, which is K plus. That will be 56-bit long. So let me create a function that will do that. It receives a string of 64 bits and generate a string of 56 bits that will be K plus. So help me with that. What should I do here? Define, for example, let's call it compute K plus. It will receive what? It will receive a string, an input, which will be the key, and it will receive a table, which is PC1. I call it PC1, I could just call it PC. What should I do inside? Since we already defined apply table, and we're just going to do return apply table of the key with PC1, with O. There is no PC1. PC1 is something that I know. PC1 is not an input. When you give me a key, I can give you the key plus associated with the key. So I need PC1. So I can define PC1 here inside, but what I'm going to do at the beginning of the file, I'm going to put all the table that we need. So since I already wrote them in a file here, let me just copy all of them. Control C and paste them here. Okay, so the one that I need is PC1. Define here. Okay, so as you can see, it should have 6 integer, because it's going to take a string of 64 bits and convert it to a string of 56 bits. Okay? So here we have compute key plus. Let's verify that our function compute key plus work. So for that, I'm going to reload the file, and we have compute key plus that is available. So I'm going to put a key here, and I want it to compute key plus. So let's use the key that is in our slides to verify it. So since I have to go to PowerPoint, let me go to PowerPoint and find the example that we have. So, okay, look at, this is the key, and what I'm going to compute should be this one. So I'm going to put the key here. Okay, I'm going to remove the space manually. Remove the space, 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 remove this one, and remove this one. So look at, this should be the key plus. Okay, so let's verify that it's the same as this one. So let's see if I can put them together. Yeah, you see both of them, no? Here. Here's my PowerPoint. Okay. So let's see. This is F1. F1, it starts well. Then we have 5D. Let's see, this is 5, this is D. Okay, of course I'm going to lose a lot of time if I do it like that, so we can just use the function that we create previously and say, okay, you are going to compare this output that gave me my program to the output that is in the PowerPoint, and they should be equal. So this is the output that gave me my program. I go to the PowerPoint slides and I copy this output. And they should be equal. So I need to remove the space. I'm going to remove them manually. So here I need to remove this space, this space, this space, this one, and this one. And they are equal. So I know how to compute K plus. So the first step is okay. What is the next step? The next step after applying PC1, as you can see, is to divide. So we have key plus, we have this part. We are going to divide key plus in two parts. C0 will be the most significant 28 bits, and D0 will be the least significant 28 bits. And we are going to do shift on C0 and D0. So this is explained here. Show you. So to get key 1, 1 shift. To get key 2, 1 shift. To get key 3, 2 shift. So look, this is key plus, which is 56 bits. We divide it in 28 bits, the leftmost significant bit and another 28 bits, the rightmost significant bit. And how we get C1? By doing one shift to the left. How do we get C2? By doing again one shift. So how can I go directly from C0 to C2? From C0 to C1, we make one shift. From C1 to C2, we make another shift. So if I want to go directly from C0 to C2, I make how many shifts? 2 shifts. So from C2 to C3, according to the table, look at, from C2 to C3, you make 2 shifts. So if I want to go from C0 to C3 directly, I will make how many shifts? 4 shifts. Because it's 1 shift plus 1 shift plus 2 shifts. So it will be 4 shifts. Okay? It will be 4 shifts. So look, I already have in the virtual machine the table of rotation. So let me show you where it is. It is there. And I already added them. You remember for the first one, 1, for the second one, 2, then 4. It is already there. So we can go from C0 to Ci directly, and not from C0 to C1, from C1 to C2, from C2 to C3, from C3 to C4. We are going to go from C0 to Ci with a for loop. So let's do a function that is called compute subkeys. So let me go back here, and we are going to do a function that is called compute subkeys. So this function will receive what? Will receive the key, and from the key will produce the 16 subkeys. So what is the first step that I should do? I need to compute the key plus. This is the first step. So I'm going to say key plus is equal, we need a function for that, compute key plus from the key. So I have a key plus. What should I do now? So if I look at the slides say you need C0 and D0. Let me show you. Okay, you need C0 and D0. C0 will be the leftmost 28 bits of key plus. So help me here. What will be C0? How do I get C0? The leftmost 28 bits of key plus. Right here. A plus, I need a range from 0 up to 28 exclusive. Now D0 is the rightmost. How do I compute D0? From key plus, I need to go from 28 inclusive to 56 exclusive. So I have C0 and D0. C0 and D0. Now I need to compute C1, D1, C2, D2, C3, D3. So let's compute all the C sub I. For that, I'm going to create, for example, a list that I'm going to call C. So C is initially an empty list. When I compute C1, it will have 1 element. When I compute C2, it will have 2 elements. Up to C16, it will have 16 elements. What should I do? Or I in range of 16, isn't it? So what should I do? Put at the end of C, concatenate at the end of C sub I. I have C sub 0. From C sub 0, how do I get C sub I? So, for example, from C sub 0, how you get C sub 1? You make one left rotation. From C sub 0, how do you get C sub 2? You make two left rotation. From C sub 0, how do you get C sub 3? You make four left rotation. From C sub 0, how do you get C sub 4? You make six left rotation. So the number of rotation is in an array. We have an array that is called, let me see, it's called accumulated rotation. Okay? So I can use this array, accumulated rotation. So the number of rotation that I need to do is here. So how do you rotate C sub 0 to get C sub I? If I give you this string, let's see. Let me call A, B, C, D, E, F, G, H, I, J, K, L. Okay, those are bits. And I want to rotate it 3 positions. What should I do? I take from D to L. And I concatenate it with A to C, isn't it? If I want to do it 3 times. And that will give me, as a result, what I need. Okay? What I need is what? Is this together, concatenated. What I need is this, isn't it? So this is this, you do it 3 times. If you do it 5 times, what will be the process? Very similar. So you skip the first 5, 1, 2, 3, 4, 5. You take those, you put them here. Then at the end, the first 5. And you will get, isn't it? So tell me how we do that. With all this explanation, I already explained the algorithm. So we have C sub 0. So from C sub 0, what should I do? I take from C sub 0, I take the element that start in this position up to the end. And I concatenate from C0 the element that start in position 0 up to this one. Isn't it? And that's it. So let's verify that our function works. So what I'm going to do here, I'm going to print the result, print C, to see if the 16 C's are correct. Maybe I print them in a for loop. For I in range of 16, we are going to do to verify that the C are correctly generated. So key, I'm going to put an integer here of a 2 character. Key is, and I'm going to show the key here. So format, and here we are going to put I plus 1, key I plus 1, because we don't talk about key 0. And it will be C sub I. So if I didn't make any mistake, it should work. So let me upload it. And we have a function that is called compute subkey. So let's call compute subkey with the initial key. So I have the initial key here. Let me just copy it. And we'll see the from C sub 1. Oh, it's not the key. I wrote key here, but it's C. Let me see sub something is, because it's not the sub key per se. So let me redo it. I need to concatenate this to the end of C, isn't it? I did a mistake. Let me see. Okay. Let's see if the keys are the same as in the PowerPoint. This is the PowerPoint, yes. So let's put it here. And let's put this guy here. So let's see the first C1. Oh, C1 doesn't work. C1 have to be 1, 1, 1, and we have 1, 0. So there is something that is not correct. So did I put the correct key? Oh no, this is not the correct key. So I didn't put the correct key. So let me copy the key from the PowerPoint. Suppress all this. That was not the key. The initial key is this one. I can't copy it from here. So I'm going to search it from my PowerPoint. It is in the PowerPoint. This is the key. Let me copy it, go back, paste it, and remove manually the space. I should use a better tools than do it manually. And see the key that it will generate. Okay, there is still a space here, I can see. Okay, so let's see. So 3, 1, 3, 1, then 3, 0, 3, 0, then a 1. I better, let me see if it allows me to copy it. Thank you, God. A little easier like that. So let's say compare string, the first C1 that I copy from the PowerPoint slide with the one that I computed to see if they are equal. Okay, they are equal. Compare string. Let's take, for example, the C7. Copy, paste the C7 with the C7 here to see if it's correct. Bingo. So we are doing fine. So let's continue with writing our code. So I need to do the same thing with D. So let me just copy this 3 line and do the same thing with D. So D start like that, like an empty list. And using D sub 0, I compute all the D. So here I could show the D, but I don't doubt it will be okay. Now that I have the C, all the C and all the D, how do I go to the key per C? So you concatenate C sub I with D sub I, and you apply PC2, which is there. Okay, so look, for example, you have C1 and D1, you concatenate C1 and D1, and then you apply PC2. So let's do that. Let's compute now the sub key. So I'm going to say, let me say here, I have an array that is called sub keys, a list, not empty. And I'm going to do it 16 times. So what should I do 16 times? should concatenate at the end what? So I need to concatenate C sub I with D sub I first. And once concatenate, I apply the table PC2. You remember that we did apply table PC2, a function apply table. So this should give me all the keys. Look, I'm going to show the keys this time. So let me put here key and the key, and we are going to show sub key sub I. I should have all the sub key correctly generated. So let me go back here, exit, reload, and we have this function that we call. Let's see, look at the keys, the sub keys, sub key 1, sub key, all the sub key. So I want to verify them with the result that we have in the PowerPoint to see if I generate them well. So they are here. So let me see if I can copy, for example, key 8. Bingo, I could do it. So happy. Okay, so let's say compare the string that I copy from the PowerPoint to the one that was generated by my program, which is sub key 8. So I know now how to generate all the sub keys. You see? So look, if you look at the initial algorithm, we have done already more than half. Let me show you the first these slides. We already have key 1, key 2, key 16. So we already did all this. We applied the PC1, we applied the rotations, then we applied PC2. So we have all those keys. So now I'm going to encrypt. So I need the round. So I need to implement the round. So let's see what is a round. A round have 4 operations. I'm going to show you the slides, maybe that is more adequate to understand what is a round. This is. So to implement a round, this is function f, sorry. I need to implement function f. So let's see. Let's define a new function. I'm going to remove that here. And return the sub key, no? Because I need a sub key. Return the list sub keys. No, maybe it's better like that. Okay, let me define now the f function. So help me with that. The f function receives what? The R from the previous iteration. Let's call it previous R, or let's call it just previous. The R from the previous iteration. And I receive a sub key, the sub key of the iteration. So remember, this previous is 32-bit long. This sub key is 48-bit long. So what is the first thing that I need to do? I take the R, the previous R, and I apply the extension table. So we have an extension table. Here is the extension table. By duplicating, for example, the 1, by duplicating, for example, what else is duplicating? The 8 is here and is here. It is passing from 32-bit to 84 bits. So I need to apply the extension table. So let's put temp result 1. So I'm going to apply over the previous R. the extension table. I have it in my file. So it will give me this 48-bit. Then this 48-bit, I have to XOR them with the key of the iteration. So we did a function XOR. Let's call the result temp2. I'm going to XOR the previous result, which is in temp1, with the key. We have a sub key that we receive here. Okay, so I already did this XOR. Now I need to apply the S table. So what do you think we are going to do now? Let me call it temp3. So we need to apply. We have a function that is called apply box. Remember we did it? So we need to break temp2 in 8 blocks of 6 bits. Temp2 is here. So I need the first 6 bits of temp2. How do I get the first 6 bits of temp2? Temp2 sub 0, 6. This is the first 6 bit. And I will apply the Xbox 1. So remember, we have the Xbox 1. We have the Xbox 2. This, I need to concatenate it with what? With apply the Xbox S2 with the second block. How do we get the second block of 6 bits? Temp2 from 6 to 12, isn't it? So I need to keep going. I need to concatenate that with, let me put it here. Let me just copy that and change it. So first block, second block, remember it's 8 blocks. So let me put just that and change it. 4, 6, 8. So here it will be 4, 6, 8. Here it will be table box Xbox 3, Xbox 5, and Xbox 7, isn't it? So here it will be what? From 6 to 18, isn't it? Here it will be what? From 18 to 24. Here I need the next 6 bits from 24 to 30. The next 6 bits from 30 to 36, isn't it? The next 6 bits from 36 to 42. The next 6 bits from 42 to 48. Remember? The result here, 48 bits on 48 bit is 48 bit. So I already passed the X table. I already did that. What is the last step? Apply P. So we have a table that is called P. It is there. It is already there. I just need to apply P to the result that we just found. So now, to get the result, I'm going to apply P. So I can just say return apply table to the previous result. The previous result is in temp3, and I'm going to apply table P. Okay. Sorry? Oh yeah, it's from 12. Thank you for catching that. To 18, 18 to 24, 24 to 30, 30 to 36. Okay. So we can verify that our f function work. So what should I do? The same thing that we have been doing. So I'm going to start Python, and I should have a f function. So the f function needs two parameters. So we have slides to help us to verify it. Look here. This is computing the f function. So let's try it. First, we need R0. So R0 is this guy. Thanks to God, he let me copy it. So this is the R of the previous round. So I'm going to copy it here. In the R of the previous round. And we need the key of the round, which is key 1. Where is key 1 here? It is here. Okay, allow me to copy it. So good. So I'm going to put it here. And let's see, look at the result. So this will be what? I just compute f. So where is the result of f here? It is there. So I should compare this number with this number, no? You see this number is the result of f. So I need to compare this number. We have the PowerPoint here, put that, okay. So let's verify. 0, 1, 0, 0 is the first block of 4, 0, 1, 0, 0. Good. Then we have second block of 4, 0, 1, 0, 1. 0, 1, 0, 1. Third block of 4 is 1, 0, 0, 0. 1, 0, 0. Last block of 4 is 1, 1, 1, 0. 1, 1, 1, 0. Okay, so my function f is done. I'm very fast, very close to the final result. So now that we have f, we can do the round. How is the round? Here is the information of the round. So let's do the round. Let's do a function that is called round that will do that. So okay, define round. So the function round receive the previous string, an input, it have a subkey, and it will compute the output. So I lost it again. Okay, here it is. So help me with that. I need to divide them in left and right. I need to divide the input in left and right. So how do I get left? F will be what? Will be the input from 0 to 32. What will be right? Be the input from 32 to 64. Good. I have left and right. So how do I compute the result? So the result will be what? Let's call it, for example, new. What is new left? So here we have it. New left will be the previous right. So new left will just be a copy of right. What is new right? So it will be the XOR. It is there. Let me put it like that. So it will be the XOR of what? Of the previous left. On what? On F of what? On F of the previous right. And the subkey. isn't it? So what should I return? I should return the concatenation of left and right, new left and new right. So new left concatenated with new right. Okay, very good. So now we can define the encrypt function. We have everything, I think so. So the encrypt function will work, will receive what? The plain text and the key, the initial key. So help me with, what should I do here? Let me show you the first slides. Slides were, okay, these slides. So first, we apply the initial permutation on the plain text. So let me put, let's call it result. Result is equal apply table the plain text. I'm going to apply the table that is called IP, and we do have a table that is called IP. Here is the table IP, the initial permutation, okay? Okay, so I am here. Then come the rounds. So before I go to the rounds, I need to compute the sub keys. I have a function. So let me define sub keys. It will be a list of sub keys. So we are going to call the function that we did. What is the name of this function? Compute sub keys. We are going to call compute sub keys. I'm going to pass it the key. So we have all the sub key, K1, K2 up to K16. What is coming? 16 round. So for I in range of 16, what are we going to do is what? We have a function that is called round. So the new result will be, I'm going to call round. I'm going to pass the previous result. Round has two input, no? So the previous result and the key of the iteration. So sub key of I, isn't it? I did compute them. We are here. We need to swap them. So what should I do? We need to swap the 32 more significant with the 32 less significant. Result is equal what? So the most significant and the less significant are swapped. So (32). I'm going to put here result, concatenate this with this, isn't it? So look at the least significant at the beginning, concatenated with the more significant. And look, we are here now. We just need to call the inverse permutation. So we do have an inverse permutation table. It is there. It is called inverse IP. So we are going to do that. So result is equal apply table result and inverse IP and return result. So hopefully everything works. Let me save it. Okay, we have something that is called encrypt. Let me put the plain text and the ciphertext. So let's find the plain text in our example. So the key is here. Let me see if I can copy the key. Yeah, I could copy the key. So let me put the key here and remove all of the spaces. Here the plain text. Where is the plain text in? I'm not sure I have it in. Do we have the plain text? Those are the keys. Yeah, we should have it in some place. This is the plain text. M. Oh. So I have to go to PowerPoint slide. Where is the plain text? It is there. So come back here, and I'm going to say this is the plain text. And hopefully it will compute the correct result. I remove the spaces. This is the result. So let's see. We have this result in another slide. Let's compare it. It is maybe it is in hexadecimal. It's not in binary. Oh, we have round 50. No. Oh, I think it's this one. Yeah. 80B9. Let me verify. 80B9. So this is 8. This is 0. This is B. This is 9. So 80B9. Then we have 9B. This is 9. This is B. So you see, we implement the encryption algorithm. So it's time, unfortunately. I'm going to send you this code. I want you to implement the decryption algorithm and do a program such as we will do this. We will put here the plain text. We will put here the key, and it will show us the ciphertext. Of course, Python, the command is called, the file is called des.py. You put the plain text, the ciphertext, the plain text, the key, and it shows you the ciphertext. And also another one that will decrypt. So implement the decrypt. We have class next week. Implement the decrypt. It's very similar to the encrypt. It's maybe 5 minutes to do the decrypt. So of course, the decryption algorithm have to walk backward to come to the plain text. Okay? Please review this video. I know it's not easy, but of course, if you don't understand the algorithm, you are not going to understand the code that I'm doing. You need first to understand the algorithm. So look at the video of the algorithm, understand the algorithm, implement the decryption algorithm. Okay, I'll see you next week on Tuesday. Remember that you have homework 1 is due. The Linux command is due. Okay, at this time you should maybe have already done it. If it's the case, you can start with homework 2. Try to work on it. Okay, I see you next week.